Welcome to the third video on the electrostatics unit. In this video, we're going to cover really the heart and soul behind this unit, and that is Coulomb's law. Coulomb's law is a mathematical relationship that we can use to help us figure out what is the attraction, the force of attraction or amount of force between charges. And so on the screen, we have a diagram here. We have Q1 and Q2 that represent two objects that have a particular charge. And then they are separated by a distance r, and that might be confusing a little bit because sometimes students think r means radius, and that doesn't in this case. A lot of times you might see r written instead as d, which stands for distance. But either way, it is the distance that is separating the two charges. And so to calculate what is the force acting between two charges, we will take Q1 times Q2 times K divided by r squared. Now let's talk about that. Let's kind of walk through that a little bit. First of all, Q1 and Q2, by now we know that those are the charges, and charges have to be in units of coulombs. And so Q1 would have a charge of coulombs, and Q2 would have a charge of coulombs as well. And notice they are the absolute value. So when we're using Coulomb's law, it is not necessary to have to put the negative or the positive in because we're going to actually determine the direction when we look at the force diagram. And so we're just going to take the absolute value of those two charges. Now, when we multiply, a charge by a charge, you end up getting the unit of c squared. So I'll write that out here to the side, c squared. All right, now I'm going to ignore k for just a second. Let's talk about r. Okay, when you have r, that's the distance that is separating the two. R needs to be measured in meters. And so if it tells you your distance in centimeters, make sure you convert that into meters. And then when you square that, that becomes meters squared. And so what do we have so far? We have on the top coulombs squared divided by meters squared on the bottom here. Now the K is a universal constant for the forces or Coulomb's law, and that is going to be 9 times 10 to the 9th. So you'll never solve for K. K is just a constant that we use. It was experimentally derived, and that is what we're going to use when we're calculating Coulomb's law problems. Now notice the funky units here. K has the units of Newton meters squared per Coulomb squared. And I write that only so you can see how everything will cancel out. Remember, my K value is going to have the units of newtons meters squared per Coulomb squared. So that's K. And then what does K get multiplied by? Well, it gets multiplied by the two charges, which remember that was c squared. And then it all gets divided by your r squared, which we know have units of meters squared. So notice what happens. The Coulomb squared cancels out, and the meters squared cancels out. And so what are you left with? You're left with newtons, and that's what force is measured in. So you don't have to memorize that. I just wanted to show you how all those units cancel out. So all you really need to know is that charge has to be in coulombs, distance has to be in meters. And as long as you have those two units correct, then everything will calculate out correctly. Now remember, like I said, we're going to take the absolute value, and we're going to get the direction simply from the signs of the charges. So the direction of a force is determined by the sign of the charges. So if these two charges were positive, they were both positive, remember, two positives are going to repel. And so for the direction, we'd say repel. If, however, one of the charges was negative, let's say the first one, those will attract to each other. And so that's how we'll get the direction, is we will know like repels and then opposites attract. So let's do some problems with Coulomb's law. All right, example 1. We have two examples in this video. Example 1, find the force between two positive 5.0 microcoulomb charges that are 4 centimeters apart. So first of all, let's kind of draw this. So here's my two charges right there. I am told that they are separated by a distance of 4 centimeters. And each one is positive 5.0 microcoulombs. So there's the first one, and then there is the second one. So it wants to first of all know what is the force, and then later on at the very end, it asks us what is the direction of the force, meaning is it attractive or is it repulsive? Now, actually, right now, I can already answer that question. I know the direction is going to be repulsive. They're going to repel each other. And I know that because they're both positive. And positive charges, if they're both positive, they're going to repel each other. So I've already answered that part. Now I just have to figure out what is the force. So remember, force is going to be found by using Coulomb's law, which is K times the absolute value of Q1 times the absolute value of Q2, all divided by R squared. And so let's plug that in. So force, I'm going to start over here because I'm going to need some space here. Force is equal to, K is my K constant, which is 9 times 10 to the ninth. And it's got the newtons meters squared per Coulomb squared. Times, my first one is 5 microcoulombs. Now remember, it can't be microcoulombs, it has to be coulombs. So to do that, I'm going to do 5.0 times 10 to the negative 6. Remember, just adding on times 10 to the negative 6 is what converts that. And the second charge has the exact same charge. So the second one is also 5 times 10 to the negative 6 coulombs. And I should have coulombs over here. And then at the very bottom, we have our distance. Now my distance is 4 centimeters, and if you don't remember, centimeters is 2 decimal places away from meters, and so we move the decimal place 1, 2 places to the left and fill in zeros, and so it'll be 0.04 meters, and then don't forget to square that. The squaring is I would say the two most commonly missed things in the Coulomb's law problems is one, not converting your distance to meters, and two, not squaring it. So down here in the denominator is what trips students up a lot. Most students don't forget to change their coulombs, but they do forget to convert the bottom, and so just make sure you do that. Okay, I'm going to go ahead and pause the video, and then try to calculate that in your calculator, and then I'll reveal the answer to make sure we're on the same page. All right, and if we calculated that correctly, we should have gotten approximately 141 newtons of force would be the force experienced between those. And I'm going to put, once again, I've already circled it, but I'm going to put that is repelling. You can say either repel or repulsive. They're the same thing. Okay, let's move on to example number 2. So it's set up very similarly. It says find the force and direction between charges Q1 of positive 5 nanocoulombs and charge 2, negative 4 nanocoulombs that are separated 2.5 centimeters apart. And I've reminded you that 1 nanocoulomb is 10 to the negative 9th coulombs. Okay, so we're going to set it up. Force is equal to K times the absolute value of Q1 times the absolute value of Q2 divided by R squared. Okay, so let's fill that in. My K constant is 9 times 10 to the negative 9th. Or excuse me, not negative 9th. That's my bad, I'm sorry. 5 times 10 to the 9th. Get that out of there. There we go. Okay, so 5 times 10 to the 9th. Newtons meters squared per coulomb squared. Okay. Charge 1, Q1, it's positive 5, but it doesn't matter. It's absolute value, so positive or negative doesn't matter. I'm going to put 5, and then nano, changing that to coulombs, I just tack on times 10 to the negative 9th coulombs. And then my second charge is negative 4 nanocoulombs, but the negative doesn't matter because I'm just taking the absolute value. 4, and then times 10 to the negative 9th as well. And then on the bottom, my distance separating the two is 2.5 centimeters. That's the same thing as 0.025 meters. And then don't forget to square that. Okay, so that will cancel out the meters squared. That will cancel out the coulombs squared. And so I'll be left in my newtons. And so let's calculate that real quick. 9 times 10 to the 9th times 5 times 10 to the negative 9th times 4 times 10 to the negative 9th. And divided by 0.025 squared, and that will get me a much smaller force than before. That's going to get me 2.88 times 10 to the negative 4th newtons. So not a lot of force, which makes sense because our charges are a lot smaller. Nano is much smaller than micro, which was the previous example. So smaller charges means smaller force. So 2.88 times 10 to the negative fourth newtons. And then what is the direction? Since one is positive and the other one's negative, opposites attract. And so that's going to give me attract as the direction there. All right, that concludes the video on Coulomb's law. We'll see you in the next video where we deal with some two-dimensional Coulomb's law problems.